all semester, all last semester? No, it wasn't the whole semester. When did we start trig? Chapter 3? Nope, those are exponential logs. Chapter 4. For chapter 4 and for chapter 5, what kind of triangles were we talking about? And what are some relationships in right triangles that we used a lot? What are the basics of right triangles? How do you solve for a side given two other sides? Pythagorean theorem. So we have a squared plus b squared is c squared. How could we solve for either a side or an angle given at least two of the following three pieces? An angle and two other sides. If we have an angle involved in any way, shape, or form, either given or finding, we can't use Pythagorean theorem, but what can we use?
Sine, cosine.
Yeah, SOHCAHTOA, sine, cosine, tangent, however, opposites, hypotenuses, adjacents. We just have to think about what are we given, what are we trying to find, and set up the appropriate sine or cosine or tangents. The SOHCAHTOA and Pythagorean theorem is how we always solve any right triangle for whatever we're missing. But the problem is, if we have these guys, these oblique guys, which oblique is just the general name. Maybe you haven't heard that before. An oblique triangle. An oblique triangle is just the general name for a non-right triangle, but it could be an obtuse triangle, which has an obtuse angle, which is an angle greater than, or it could be an acute triangle, where all three of the angles are acute, aka less than. Wait a minute. An obtuse triangle has how many obtuse angles? Why can it only be one? Has to add up to be 180, and if you have somebody over 90, then don't you have two angles that have to split something less than 90? So you have to have two acute angles and one obtuse. Nice. This relationship, law of sines, how many of you guys have seen it before, or at least you remember the name in geometry? Was it geometry? I think it was geometry. Law of sines. Now, law of cosines, you might have seen that one in geometry. Maybe you saw it in algebra 2. I don't totally remember. In chapter 6, here's what it's going to look like. 6.1 and 6.2 are building a foundational mastery in these formulas. Law of sines, law of cosines, and two area of triangle variations. Each section has a law. Each section has an area formula. So law of sines and an area formula, law of cosines and an area formula. Yeah, you guys. Building foundational just skills of plugging in stuff that you're given, trying to find extra things, trying to find unknowns, trying to analyze information, trying to figure out what goes wrong, what goes right. So hopefully in some senses they're kind of basic. Getting used to formulas and being able to use them. But then section 6.3 says, okay, we've reminded you of these formulas that are helpful for non-right triangles. 6.3 says, let's take all the stuff you know about right triangles, like specifically right triangles, not like T-proofs and unit circles and all that sort of jazz, but like actual right triangles. Pythagorean theorem, SOHCAHTOA. Let's take this new stuff with law of cosines, law of sines, non-right triangles, and let's introduce some physics to it. Precalc is pre-everything you know. We haven't gotten into pre-statistics, but it's coming. We haven't gotten into pre-probability, but it's coming. We haven't gotten into pre-calculus, although everything, like all the skills that we're building are kind of helpful for that. We haven't gotten into pre-physics, but we're about it. Okay? Which is really helpful, because some high schools, one of our kids is at Berkeley right now, and she's taking a physics class this semester. I think it's the first one of the series that she has to take for her bioengineering, whatever major she is. She's like, man, almost everyone's taking physics, if not AP physics, because some high schools require a basic physics class like a basic chemistry class to get a basic understanding. Our school tries to allow you to have more AP options, and so we don't require 2 basic sciences in high school. Yes, you did physical science in middle school. It's good. It's a little baby foundation, but anyway, physics is a come-in for some of you. Any STEM, pretty much, which is science, technology, engineering, math. Physics is just one of those you have to get through. Not most of you will pursue a career in physics because it gets kind of crazy and out there, especially like astrophysics and string theory and parallel universes and all sorts of craziness. Not crazy as in ridiculous, just crazy. Crazy hard, crazy out there. You should talk to Gavin. Gavin sat in on a astrophysics course at UCLA last year. on the AP Chem, AP Calculus field trip. Anyway, loved it though. But it's crazy. You're not going to necessarily be pursuing a career in physics, but it's one of those foundational kind of gen eds for a lot of majors. So we're building up to section 6.3, building up to where we get introduced to vectors. That's not all of physics, but it's a little bit of it, vector diagrams. And you need to kind of know triangles. And to be honest, you're not going to have to necessarily in this course use the law of cosines and law of sines a lot in that pre-physics section. But you'll see, I'll show you kind of where it comes into play, and a lot of that dealing with forces acting on an object and things sliding down inclined planes and how gravity is working with like force that's perpendicular to the surface and all that stuff. It really comes back to being able to deal with triangles. So we're going to say, okay, let's expand your ability with triangles and talk about what if it's not right? What can you do? You know what I mean. Not because it's wrong, but it's just not with the right angle. How do we deal with that? Do you know how to deal with it? Enjoy using your calculator. You're going to use it all chapter long. Degree mode all chapter long. But there are some funny things that can happen. Now, first of all, this is one variation of law of sines, but have you guys noticed there's like a whole blank space with a 4? What would happen if I were to take the reciprocal of that first statement? Because the law of sines, it doesn't say like, hey, do 2 equal signs. That's awkward. It just says you can be him, you can be him, he can be that, he can be that. It's an equivalent statement that says, hey, you can set any of these equal to any other one. But as soon as I change the orientation, what must I do to the rest of the proportion? Yeah, I just have to flip them off. Now you guys will probably see it as we practice in examples, and it won't be a big deal. But basically, this one is really helpful when we're solving for sides, this variation. And then this one's going to be really helpful when we're solving for angles. Now the nice thing is in section 6.1 with law of sines, they're so similar. If you have one memorized, you have the other one as far as like, oh yeah, sine of angle over side, side over sine of angle. If you have one memorized, you should be able to remember the other one. And it doesn't matter if you have an acute or an obtuse angle, the relationship still holds, the proportionality statement still holds. Bless you, bless you. But maybe just a few of you are trying to be like, wait, what are these down here? I know I've seen them. I know we did them, hopefully, in geometry. Wait a minute, wasn't he a bad one? Anyway, what are the A's and S's standing for? A is for angle and S is for side. Angles are uppercase, just a quick geometry review. Angles are uppercase letters, sides are lowercase letters. Angle, angle, side, angle, side, angle, side, side, angle, or vice versa, whatever's. They were congruent statements. CP, CTC, maybe some of you remember that one. Or how to prove that 2 triangles are congruent. That's when you guys were doing these, and that's when this guy broke down, but we're not doing that. We're not doing geometric proofs. We're not trying to like do a given and a prove and a statement 1, 2, and 3 and the postulates and the theorems. Instead, we're just saying, what if they give you 2 angles and then a side? Or what if they give you an angle and then a side and then an angle? This is like if you were reading around the triangle, how you would think of, oh, they gave me this, this, this. This one's going to be dangerous, just kind of like it was before. Before it was illegal, now it's just ambiguous, and we'll see that in just a bit. But this first one, anything with 2 angles, anything with 2 angles. Not 3. 3 I'm in dangerous waters, because if I only have 3 angles, that triangle can be however small, however big it wants to be. But if I'm given 2 angles, law of sines is gorgeous, it's easy, it's straightforward. And in this one, why did I call it angle, angle, side? I guess I could have called it side, angle, angle, right? If I'm reading side, angle, angle, I could have done that. Angle, angle, side, either way. Because that's what's been given to me if I read it in order, from left to right or from right to left. How's my picture? Is it like true to form with what you guys know of the angles that I've given you? What do you think? How would you know for sure? What do you always have that can always measure a 90-degree angle? So how are we doing? Is that a little bit over 90? Yep, I was going to say. It's a little over 90 because it's a little bit bigger. So I was pretty true to form, but question, if you're just drawing a random triangle ABC, do you necessarily have to make the picture match your information? I'm not going to give you protractors and rulers. However, especially if we're building into physics, if we're trying to model situations or forces acting on an object or motion and movement in succession, it might be helpful. It might be helpful. And especially since there was that weird SSA, ASS, whatever, the ambiguous dude who's going to cause us issues. The more you draw, at least somewhat according to what you've been given, the easier it might be, especially in the physics. Okay, but this one, some of you are already even thinking, I know, of the formula. What orientation should you guys use? Side over sine or sine over sine? They both sound super similar. Just super quiet. What do you think? Side or sine? Angle or side? Side. Okay, so if we do side, why am I going to put the 5 over here? Any ideas? If I put the 5 there, what goes down there? Sine of, yeah, we just put 45, right? Because whatever side you put, the opposite angle, or whatever angle you put, the opposite side, that's how we do the pairing. Cool. Diego, make sure you're focused because I'm not sure you're totally doing this problem with this. But what's going to go over here? For most of us that are pretty lazy, we're not even going to think very hard. We're going to say, oh, no big deal, sine of. Yeah, why not just do the other angle that's written? Whatever. Oh, okay, but hold on, we have to think for like a whole second. What side are we going to put right here? C. Quick reminder of our triangle. The side is opposite the angle, so that's little a, so then this one's little c, yeah? So we're missing over here on the side, if they do say solve the triangle, it's like, all right, whose angle? That's an angle sign. Some people get a little confused with a little angle shortcut. We're missing angle, angle A, and we're missing side A, and we're missing side C. I guess we could have gone after another piece of information. I just went straight to the formula. I want you guys to go ahead and solve this. With decimals, go ahead and give 2. I'll probably always give 3 because that's my calculus training and somewhat my training for you guys. But as you're plugging in, Nikki, what's up, kid? Okay. So as we're throwing it in the calculator, why didn't I do sine over side? Why didn't I do the angle over the side? What's so easy about how we can solve this now? Since the unknown is in this upper left-hand corner. Solving is as easy as, yeah, multiplying. That's it. Just multiply it to the other side in your calculator. Just throw it in. Now, it's not that big a deal that you do this right now, technically, because of PEMDAS. PEMDAS just says multiply / divide from left to right as far as order of operations, and your calculator will understand those proper order of operations if you do them right here, as far as, hey, sine, literally, 5 divided by sine times, then you have the other sign. You'll be fine because of PEMDAS, but in future parts or in future problems, especially in section 6.2, you will not be as fine if you just randomly hit the division sign and not make it a fraction. So can I just do a quick reminder of you guys, something basic that'll help you out when the formulas get harder? Can you just hit the alpha y equals for me? Hit the alpha y equals. Like you can clear this and do it again. The alpha and the y equals. Most of you, as long as you don't have that little yellow button on your calculator, have the older ones. Unless you have the yellow button on the older ones, it's not going to work. You're going to have this cool hidden menu come up that you can hit enter and you can do little fractions. What? From the yellow button calculator to the newer calculators, they put in a new operating system. So sadly, like we have the ability in any of these calculators, or the light up screen ones for sure, we have the ability to stack things or have exponents go up, but the older calculators couldn't because it was on an older operating system. But anyway, This is going to be really helpful because as soon as you have that guy, you can go ahead and stack it exactly how it shows up in your formula, and then you'll never be wrong. Once again, you're going to get the same answer this time no matter what, but it's going to be super helpful if you guys start using that alpha y equals to kind of orient all of your information and get the whole numerator together, whole denominator together if it ever got worse. But anyway, we have what? 6.83 as our side C. Okay, where should we go from here? Who else is missing? You guys want to tackle next? Side A? I think we should go to the 30 degrees too, but why did someone say 30 degrees? They already filled in A, but how'd they do that? Yeah, as a 180, no big deal, right? So maybe that would have been the easiest place to start. And now that we have that, now it's no big deal to just say, oh, go find side A because we have that sine of 30. You guys get to technically, now wait, eyes on me real quick. Don't you technically have a choice of who to put in the other statement? Because you have two pairs, right? You have 105 with his 6.83-ish. Oh, I rounded him. Or I have my 45 and 5. Always, 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 unless you're forced into using something that you already found with decimals, always use the most precise pairing possible. Meaning, I knew 5 and exactly 5, 5.000 for infinity 5, like actual 5, and 45 were measurements to begin with. 6.83, remember, was rounded, and as soon as you round, what do you introduce? As soon as you round, and you use that rounded answer, what's technically present? Error. Yeah, a little bit of error, a little margin of error. Now, I know with sig figs, you guys have been trained, like sig figs are sufficient. Yes, in science, sig figs are sufficient, but in math, we try to keep it as precise as possible for as long as possible. So final answers can be rounded, like 6.83. That was sufficient. That was okay. That's the degree of precision that they wanted. However, if we're trying to find another side or another angle, we don't want to introduce more error. Now, the nice thing is in your calculator, if you were to use 6.83, let's see how far, let's not even worry about seeing how far off we'd be. Let's go ahead and see if we were to solve, we would throw that sine of 30 on the other side. We're just multiplying. And we can get that, we had 5 again, right? 5 sine of 30 divided by sine of 45. Once again, PEMDAS will be totally fine this time, since we just have a simple multiplication and division. But what would we have needed to have done if we wanted to use the 6.83? If we wanted to use the 6.83-ish, we would have had the sine of 105-ish. So then what would have changed is we would have had the sine of 30 multiplied by the 6.83 divided by the sine of 105, so we would have used the other pairing. Let's see how far off it is. Is this far enough off that's going to mess us up with 2 decimal places? Not this time. But can you guys see how there is some error right here in the tens, hundreds, thousands place? If I was to round right here, it'd be off. And imagine if I was to use a rounded answer in one step, and then another rounded answer in another step, and then another rounded answer in another step. All of a sudden, I could have the wrong decimal, and that's dangerous, especially with multiple choice answers. So instead, what I recommend or remind you can do, you can always go up and grab the whole thing, right? Just use your up arrow, copy and paste it by hitting enter. Even with the older calculators, you could have also gotten that by hitting second enter. Second enter. You can go back on the older calculators too and grab whatever it is you want. Second enter. You can go back and grab previous submissions, or you could just do second negative, I think. Second answer. Can I go back even farther? Oh, I can. That way it lets me steal the one right above. But with the newer calculators, for sure, you can go back and steal that one. You can say, I want that guy to 6.83 blah, 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 times the sine of 30 divided by the sine of 105. And then we can see how close we are to the actual. So 3.533553339. See, that one is exactly the same all the way up until all the decimal places that the calculator includes. So once again, if you want to use something that's not nice and precise, if you want to use where you've rounded, use that full number from your calculator, not the rounded one. Just to try to introduce as little error as possible. I didn't even write it down. What was that answer again, guys? 3.54? Or isn't it when you round it, isn't it 5.5? Oh no, it's just 5.4. Okay, my bad. Done, done. Everything's solved for. Yeah.
When you put something into your calculator, like sine of something, you have to put, if you put degrees on the number, will it be a different answer?
It shouldn't be because you're in degree mode, and so it's assuming its degree as soon as you're hitting trig. As soon as you're hitting sine, cosine, tangent.
And why did you do sine? Like, can you just choose?
Oh, I did sine because I'm using the law of sines, because that's the one such that if I have two angles and a side of any non-right triangle, I can solve for what's included. Does that make sense? So what if you don't have a picture? Can you guys try to solve it without drawing a picture? And then if you get stuck, it's okay. Draw an A, B, C, and label stuff. You might not know exactly what this is. Is it angle, side, angle? Is it angle, side, the A and the B and the C? That might be confusing if you don't have a picture, but let's see if we can still plug into the formula. The formula needs pairs. The formula needs pairs. Maybe you guys think of putting a lowercase a up here in the side? Or a lowercase b? Not a lowercase c, a medium. Or a sine of c. Which way would you go? Once again, if you want the ABC triangle, go for it. Draw it. Sketch it. We're setting up a proportion. Two ratios equal to each other. Both oriented the same way, lowercase over sine of uppercase or sine of uppercase over lowercase. Sides on top or signs of angles. If you guys don't mind, I kind of want to go off of what your brain is naturally doing. What are you putting in that upper left-hand corner? No, just go for it. What do you want to put there? We only have three things missing. We only have side A, side B, or angle C. What do we put that? A? Yeah. So if we're doing A, then down here would be sine of 35. Over here would be 10, because he's the only side I need, and I need to fill in three pieces of information with only one missing. So then what's my, wait a minute, I don't have a pair of information. I don't have a given angle with his side. But what do you already know? Two angles, subtract from 180. Did you guys already do that? Who are you missing? 80, good. That adds up to be 100. So see, once again, if you're given two angles, everything's golden. Even if you're not able to go straight to the three pieces of information you know, to solve for the fourth that you don't know. With two angles, you can solve for the third, and you're good. Once again, you guys see why I'm putting that lowercase up on top, right? So all I have to do is just multiply this guy to the other side. So far, everyone who has a calculator in the room is all working, right? You'd be letting me know if there's an error that's popping up. So if so, we need to deal with that. Or if your numbers are not matching ours. What'd you guys get for little a? Am I crazy? Am I in radian mode? Oh, I'm in radian mode. Thank you. I was like, mine's There we go. Thank you. Now I'm good. That's something that if I didn't realize that now, if I were you, I'd go home and do homework and get all the answers wrong in my radian mode. And that's right, coming around. Okay, so good. 5.82, and now we see a solve for little b. Little b. I mean, that's obvious as far as who goes down below. They have to match up. But who'd you guys use over here for the other ratio? Yeah, use the one that you know. Why have to go use all the nasty rounding stuff? You guys already to the point where you just move that sign of 65 to the other side to save time? My more geometric ones. We've been doing a lot of algebra this year so far. Yeah, trig, okay, it's kind of visual, but it's kind of still algebraic. This is where you get to shine. What do you guys get, 9.20? Sweet. Is this homework feeling bad? No. It's a simple formula. It's a plug-in chart, right? Simple formula with a plug-in chart. Until we get here. Until we get here. Can you guys not even worry? Hold on, pause. Don't even worry about the notes yet. Can you just take a second and just try to plug into your calculator or plug into the formula? Because you just did that. Most of you didn't even draw a picture. You went straight to log signs. How would plugging into the formula be hard or be different or be difficult? Who are you missing? Side? C. And angles. And. Okay, how is that different than the other two things that we've done? We're missing. We already had 2 angles and all the rest. Now we only have 1 angle, so we're missing 2. Can we go straight to 180 minus? No. Okay. We have a pair. You guys see the pair, right? Let's go ahead and put 3 over sine of 20. We already have that, so then over here we can put equals b over, wait, but we have b. Where's our unknown now? Do you remember at the very beginning when we were writing the formulas and there was that or variation? I said putting the lowercase on top is really good for solving for sides. But if we need to solve for angles, why don't we flip that orientation and why don't we say, okay, fine. The only way to put this information together is A with A and B with, okay, B. What's the problem about our uppercase B that's in there? Who is he stuck in? He's stuck in his sign. Now, can we still multiply to the other side? Yeah, we totally can. No big deal. Multiply the 5 up. Like, that's not a big deal. But the problem is, whatever you get when you plug into your calculator, is it going to be the final answer? So technically, some of you might be throwing this in your calculator as we speak and writing down a decimal, which isn't bad. It's not wrong. I don't want you to think it is. But it makes you keep track of an extra decimal, write down an extra decimal, take an extra step. Whereas maybe you could have just thought ahead and been like, how do I get to big B? How do I get rid of a sign? What do you remember? Yeah. If you were ever to be in a physics problem and you needed to get to an angle that was stuck inside a trig, you can always do trig inverse. But you guys notice there are words up above like ambiguous and painful and 3 blanks as to 3 different options for how many solutions. Now hold on, first of all, you're in degree mode. Side inverse. I'm going to do it up here on the screen so you guys can see. I'm even going to use that nifty fraction feature. So I can do my second sign. I can do all of this at once and not have to introduce weird error stuff. I can get my nice nifty alpha y equals fraction bar. I can put my, if I even remember it, 5 sine of 20 over 3, all up in here. 5 sine of 30. I could even use unit circle if I wanted, I suppose. This one is totally something I should have memorized, but it's okay. We're using our calculator. I can get an angle B. 56.44. Really quickly, back me up. You guys agree? Oh, is it 20? I remembered it wrong. Not unit circle then, huh? It's okay. We have this little nifty feature of copy, paste, and then redo. 34.75? Okay. But some of you might have been listening and heard me say we have an option for angle B. 34.7. Now go ahead and take a second, or 2 or 3. Take a couple minutes. I want you to go ahead and if you haven't yet, write down the notes on this page. Finish solving this option for this triangle. Finish solving this option for this triangle. A number popped out when we went to solve, and as such, this is not a zero solution problem. This is at least a 1 solution problem. But it still could possibly be a 2 solution problem. But for right now, 1 solution, 1 possible triangle starts with angle B being 34.75. So go ahead and finish off with law of sines. Or maybe with 180 minus, whatever you need to get in. The rest of this triangle with angle B being 34.7. Please underline some notes and then finish off the triangle. I will too. I think this is the end of that first option. Be able to go through all the, let's pretend we have this angle and different sticks of different lengths and what the two would look like. We're not going to be able to figure out what they both look like today, but I can show you the or. First of all, anybody match with my answers? Are we good? Give me a thumbs up real fast. Okay. So we finished off that triangle just using the scales that we'd already used. The one thing that was weird was this little sine inverse dude. Okay, but there is technically an or. Now right away, this worked in your calculator. If it didn't work, if it said error or undefined, and you put everything legally in your sine inverse, it could have been a no solution impossible triangle case. Because I got an answer, I knew there was at least 1 solution, so I finished it off. But to check for the second solution, this one should be this one should be the acute option. We can double check tomorrow that this is also true, or always true, I should say. That sine inverse will always be the acute option. But there is a chance that every acute option also has an obtuse option that would still work. Once again, tomorrow I can show you the pictures as to how it's possible for that angle, those two sides, to be both acute or obtuse. Not at the same time, but to be an acute option or an obtuse option. All we have to do, though, is just check whatever angle you're solving for, which in this case is angle B. It could have been a sine inverse, or it could have been 180 minus the sine inverse of whatever it was that you were solving. So in this case, if I had done 180 minus, I just have to ask myself, could this also have made a legal triangle? What's 180 minus 34-ish? 0.75-ish. I'm doing that nasty rounding. Check it. That would have given us 145.25-ish. We have to check tomorrow the decimals. But hold on, pause. How do you know? How do you know if this makes a second triangle or not? We have to compare to the given. And guys, what angle was given over there? Does 145 plus 20 leave space for a third angle? Yes. There were 2 solutions in this. Alright, tomorrow we'll come back to it. We'll go ahead and try to see a picture as to why, but otherwise, right now, you have the basics. Doing most, if not all, of them. Bye, guys.